As we move on, we're going to compare problems like today with problems like yesterday, or in 7.3. In 7.3, you would have seen a problem like this. Log base of 8, 16. And you would have had to figure out, okay, I got to get a common base. So you would say 8 to the x equals 16. And then you should probably figure out that, this is 2 to the 3x, and this one's 2 to the 4th. Because 2 to the 3rd is 8, and 2 to the 4th is 16. And then you would say, all right, well that means that 3x is equal to 4. And then you would say x is 4/3. And you would have your solution. So before, you could get a common base on both sides. In this example, the common base was 2. But in the new problems today, you're going to have something like this, log 7 of 10. And you're not going to know if you do 7 to what power is 10. You have no idea how to solve for this because there's no common base between them. I'm going to write that down. No common base between 7 and 10. Okay? So what you have to learn how to do is this thing called change of base formula. So if you have two different types of bases, you have to figure out how to give them the same base. Now when we use this formula, let's write this down. When we change base, we use base 10. Why do we use base 10? Because it's in our calculators. Now if you were to ask your parents or your grandparents why we use a base of 10, they would tell you because that was what they had to use on the charts. And I'm going to explain to you a little bit about how people before we had these really nice calculators, how they had to do the change of base formula. It's very difficult. Now if you are interested in why the change of base formula works, this is kind of the proof of it. But what I'm going to do with you is I'm going to walk through an example and I'm going to use your calculator and show you that it works, that it is true. So let's go to problem 3 and let's try to figure some stuff out. Now, it says use the change of base formula. What is the value of each expression? Look at A. Now what you should be able to do, okay, let's do old and new. You should be able to do this one the old way. Okay? It is possible. You would say 81 to the x power is 27. And then hopefully you would remember that this is a base of 3, 3 to the 4th, so we do 3 to the 4x, 3 to the 4th is 81. And over here you would do 3 to the 3rd. And then you would move along and you'd say, okay, well that means 4x equals 3. And that means x is 3/4. So could you do this the old way? Absolutely. But I want to show you how to do this the new way. The new way would do this. You would take your calculator and you would change it to a base of 10. Let's write this down. Change to base 10. Now if we change it to a base of 10, here's how easy it is. You just do the log of the big number. Notice how I made the base 10 over the log of the little number, the base, 81. So you just put like the answer over what the base was. Notice now it's in a base of 10. I just stick it in your calculator. So and use calc. And you can use a basic calculator. In fact, here I'll find my basic calculator and I'll show you. You don't have to use the big fancy ones. Okay, I think even your computer at home should have this. If you do, there, that looks pretty good. Log of 27, close your parenthesis, divide by log of 81, close this parenthesis, you will get an answer of 0.75. Now is 0.75 the same as what I got? Yeah, 0.75 and 3/4 are the same. Now, how can you check and see if this is correct? Well, take your calculator and go back to the original. Do 81 to the, there it is, 81 to the 0.75 power, and watch how I get 27 as an answer. Let's try part B. This is really like 5 to what power is 36? Well, there's no way that you know how to do this, okay? Because there's no common base. Can't do this the old way. So what we're going to do is we're going to make it a base of 10. Let's write that. Make base of 10. So if we make it a base of 10, we'll do log of 36 over log of 5. And notice they're in base 10. So now I can use the calculator. And I'm going to do log of 36 divide by log of 5. And I get my answer of 2.2265. Let's go ahead and today round to the nearest hundredth, at least in this problem. So we'll say that equals 2.23. Now, how can you check this? How can you see if this is correct? Well, you go back to your original and you say that means that it should be 5 to what I got. Remember, logarithms are exponents. And if you check this, ready? 5 to the 2.23, I get very, very, very close to 36. Now, why didn't I get 36 exactly? Because I had to round. Let's use the change of base down here and the old way if possible. It is important that you remember how to do the old way. Okay? Now in this one, we're going to try it the old way, and then we're going to try it the new way. The old way, you would do 8 to the x equals 32. And then you would use a base of 2. And you could say that's 2 to the third with an x equals 2 to the fifth. You would then say 3x equals 5 and x equals 5 over 3. Perfect answer. Now let's try it the new way. You would just take log of the, kind of like the answer, over log of the base. Notice we're using a base of 10, so we can put it into the calculator. Okay, so we do log of 32 divide by log of 8. You're going to get a decimal. You should know by now in this course by Algebra 2, you should know that that is, in fact, 5 over 3. If you're not sure, make sure you stop by. I want to teach you how to learn how to get fractions from decimals. If you can get a fraction, you always want to get a fraction. This is a lot more accurate than that would be rounding. Now, how can you check if it's right? You simply take 8 to that answer, and look how you get 32. Let's try the next one. This would be a log. You would say like 4 to what power is 18? These have no common base. So what we have to do is use the change of base formula. I'm going to change everything to a base of 10. Now we put it in our calculator. And we're going to do log of 18 divide by log of 4. And we get a pretty ugly decimal that cannot be made into a fraction. So we'll do 2.08. How can you check if you are correct? You take 4 to the 2.08 power. And you should notice we get pretty close to our answer of 18. Again, it's not 18 because we had to round. The back page here I find very confusing to explain. If you would like me, if you're going to be like a chem major, I would love to sit down and describe this to you. Otherwise, what I'm going to do is I'm going to leave this problem alone, And again, but if you're trying to, like, in your future, you want to be a chem major or a science major, please come. I want to walk this through with you so you understand it. But for everything considered, what we've gone through in the lesson is all we need to go through. See the lesson check? If you understand these, you've understood our lesson. All right, example 1. If you would like to go ahead and see if you did it right, you should get a final answer of 2. See if you can do that. If you can do that, you understood the lesson. In example 2, you would get an answer of 1. See if you can do that. If you can, you understood part of the lesson. In example 3, when you expand this, you should get log base 3 of x minus log base 3 of y. In example 4, if you want to take the time to check it out, you would get 2 log of m plus 5 log of n. Check it out. If you have questions, please ask. In example 5 is probably the hardest. You would get 1/2 log base 2 of x. If you have any questions about these, please let me know, especially 1 and 2.